You had a really good question about the fit function, and so I wanted to make sure I answered it. Sorry, it's taking me so long. Also, I do want to give a quick shout out to just in case anyone else is watching this video by any chance they stumble upon it. I want to give a quick shout out to Matt from The Joy of Vex. Um, Let me actually put up his website here. This this guy is really amazing, and his resources are super great. And I pretty much learned everything I know just from doing this. He was the first one who really kind of broke it down in a way that finally made sense for me. So I really want to give a shout out to Matt. He's also got a Discord channel, which is a great place to hang out. CG Wiki, like, definitely support if you can. I donate a little bit to the Patreon every month because it's not very much, but it's the least I can do considering how valuable this resource is. So I just really want to make sure I give credit to the right people. So the folks at CG Wiki definitely get a lot of love from me. Now, if you are familiar with going through the Joy of Vex course, you'll recognize this scene because it's kind of the one that they use to teach stuff. So I'm gonna be using it as well. So, Destructive, so your question was, so you got to the part where they were having you using the fit function, and you said, if I'm not mistaken, everything that goes into the fit are floats. That's a good question. Let's just start there. So let's go fit vex function, and I'm kind of diving through Houdini's documentation. And if we look at this, it actually tells you that there are two float functions. You can use it on floats, or you can use it on vectors. So that's really good to know. This kind of comes from, I think what Vex is based off of is C languages, and maybe even specifically C++. And one of the really useful things you find about C++ is they have what are called overloaded operators, which is a scary word, but all it means is that let's say you do 2 plus 3. So you're adding two integers there. So the addition operator says, I see, you have an integer and you want to add it to another one. Okay, I can do that. I can handle integers, no problem. But then let's say you do like 2.3 plus 1.33333. Now, it would be really annoying if you had to use a whole different plus function for all the different types of numbers, right? But what the plus function, or the plus sign, what that operator does in C++ is it's smart enough to look at what you're giving, and it says, ooh, I see, you're giving me two floats, not two integers. Well, it just so happens that I know how to handle addition of floats as well. So that's kind of the same thing that's happening with the fit function. If you give it floats, it knows, I see, you want me to use my float version that I have. If you give it vectors, it will say, ooh, I see, you're giving me vectors. Okay, no problem, I can handle vectors, no problem. So that's the first part of your question. Most of the time you will be giving it floats, but you can give it vectors. So keep that in mind. Now, so that was the first part of your question. I thought it was really good. Now, the next part of your question, I think, is probably the part that most people are interested in, which is, how do we know what values go in the parentheses? Is it just fiddling until one produces the right result? So the answer to that is, it is just fiddling until you get the result you want. But you can help yourself figure out what might want to go in there. So let me rephrase that. Eventually, it comes down to just fiddling. But you don't have to go in blind. You can use some information. So I'll show you how. So let's say I have a really simple example prepared, and I'm going to do it from scratch. So let's say we've got this grid here, And the first thing I want to do is I want to just initialize its color as black. And let me put the display flag on there. So now every single point now, and actually I'm a really bad guy here. I always, and I preach it, and I just forgot to do it. Always have that geometry spreadsheet up. That's crucial. So if we look at what's going on here, we have a CDR, a CDG, and a CDB channel, and these are all initialized to 0, 0, 0. Sorry. I'm really sorry about this. I will edit this part out. I just got a text. So we initialize the color to 0. And then let's say we want to have an effect that's triggered by a color. So for example, we could make some of these points red. And then the idea is that if you are a red point, then you can go ahead and trigger the effect. Let's say we want to trigger particles or something like that. We'll trigger the particles where the red is, and we won't trigger particles where the black is. So, we could paint it on. That's one way to do it, but we could leverage the power of Houdini, and we could say, okay, we are going to make a new float. We'll call it D. It could be anything, but it's going to be based off of a random number, and the seed we're giving it is your point number. So keep in mind that these attribute wrangles, one really important thing to understand is they run in parallel over every single point in your geometry. So every single point has a point number, right? It's right here, 0, 1, 2, 3, 4. So this random function, it takes 0 and it gives me a random number. And then for the next point, it takes 1 and it gives me another random number. And you see D is going to end up being different for every single point, or at least pretty close to different. Now, I say random number, but that's not exactly true. The thing about the rand function is it gives you a number between 0 and 1. How do I know that? It's just experience. But one thing that I really think can be helpful, especially when you're first learning, and I wouldn't do this if I was trying to work fast, but if I was learning, I would totally do this. You can go ahead and make an attribute, and we'll call it D. So let's go over this syntax really quickly. This is really important. F for float, @ for attribute, and D for your name. So your type of attribute, your sign that you want to make an attribute, which is the @ sign, and then your name. Let's call this something a little more descriptive. Well, actually, no, D is fine because I'm going to basically set it equal to D, so I think that's the best way. And now when I update my code, look at our geometry spreadsheet. We have a new attribute here because I made it with this F @ D piece of code. So now, one great thing about the geometry spreadsheet is that you can toggle by the highest and lowest values by kind of left-clicking. It will sort it for you. So for example here, I'm toggling and I'm seeing that my highest value for my X position is 5, and my lowest value for my X position is -5. Now, check out what's going on here with D. We don't have 0 and 1, but you see it's so very close to 0 that we kind of just say it's 0. And with this number, you see the highest it ever gets is so very close to 1 that we basically just say it's 1. So now we bring in the fit function, and now it makes a lot more sense, because now what we could do is we could make your red channel equal to D, right? And if you look at this, now it's going to be a one-to-one relationship, right? Whatever the value is for a point D, that's going to be the value for its red channel. But let's say we run the effect and we realize, oh wow, this is too many particles, it's triggering too much. I just want to tone this down. Instead of maybe going from 0 to 1, I'd rather it go from like 0 to 0.5. Well, that's where the fit function is so powerful and so useful. So let's go ahead and we'll write our fit. And the fit function needs to know, what do you want me to fit? And we say, hey, we would like you to fit D. That's the value we want you to change. And then the fit function says, okay, well, what was the smallest value that that thing used to be? Well, let's see here. So if we look at D, oops, I broke it because my code's not updating. Let me just comment this out real quickly. So that, okay. So we see in the geometry spreadsheet, it's almost 0, right? So for our what's called the O min, or kind of the old min, we'll choose 0. That's the old minimum. So it's kind of tricky because it's like old and then new. But another way you could think about it is, this is what I have. The first two numbers that you put in your fit function. So the first thing you put in your fit function is the name of the thing you want to change. The next two numbers are what you currently have, the smallest and the biggest, the min and the max. And then the next two numbers are what you want the new min and max to be. It really confused me when I first used the fit function because there were so many numbers. I just kind of was like, there's so many numbers, like what's going on? But I really think if you break it down like that, it makes a lot more sense. So we have our D because that's what we want to change. We know that what we currently have is a 0 for our smallest number and a 1 for our biggest number. And what do we want? Well, we still want our smallest number to be around 0. So I'll do 0. But remember I said I think we want it to emit about half as much red as it has been emitting. So we can go ahead and say, hey, our new max is going to go ahead and be 0.5. And now watch this. When I update my well, so here's one thing, a silly thing that I forgot to do. I forgot to go ahead and assign it to D. And then I think what I need to do actually is reverse the order of this. And these are frustrating things that can come up when you're coding, but the assignment operator works left to right, so you have to say, I want to assign this to this. It doesn't work if you switch the order, so it's just kind of a tricky thing. But notice that if I comment this line out, you can see it's maybe hard to see on the screen, but the amount of red immediately gets cut in half. And if we look at our attributes, look at our D value. Our D values are still between 0 and 1. But look at our red channel now. Now our red channel only goes between 0 and 0.5. So this was a really controlled example where I knew exactly kind of what I wanted to do. But you're not always going to know that. So one thing that can be really helpful is, let's say I know I want it to emit less particles, but I don't really know how much. What you can do is you can make a channel here, and I'll even call this something like new red max color, something really descriptive. And then remember what we learned in our last lesson, we can go ahead and click, anytime we have a channel call, we can click on this really nice little button here. So I forgot a parenthesis, so my bad. But we can click on this little button here, and it will go ahead and make that parameter for us. So now if I change this to 1, that's what I started with. And if I change this to 0.5, that was the second example that I gave. But now I have a slider, so now I can try a bunch of different things. And this is really useful if you're not sure exactly what you want. You're like, well, I know I don't want it to emit fully red, but maybe I just want a little less red. Or maybe I need to tone my effect way down and bring it all the way down here. Right? But either way, this is how you use a fit function. I hope that was clear. I hope that makes sense. Hit me up with any questions. And I'm actually going to follow up with a more exciting example. I know this one's a little bit straightforward. I will do a cool example on how you can actually use this in maybe a production environment. But for now, I just want to get the theory out there because the fit function is a really good one. It's definitely a go-to one for me. And I hope that you will not be scared of it anymore, and you will find it to be a helpful tool in your tool belt. So anyway, that's it for this video, and I will talk to you guys soon.